Welcome. So on this case, we're going to be working out some examples for the ambiguous case of the law of sine. So let's start by looking at example one. Now, take a look at how the information is given to us. So the information is given to us in the form of side angle. So if the information about a triangle is given to you in that form, it will be a good idea for us to think about the ambiguous case of the law of sine. But notice how the information is given to us. Here we have that the side opposite of the bigger angle, it's definitely greater than the second leg. So 22 is definitely greater than 12. And recall from our previous lesson that if the third side, which in this case, it's always going to be the side opposite of the bigger angle, if the side opposite of the given angle is greater than the second leg, then that is one of the cases where we can only create one triangle. So the ambiguous case of the law of sine states that we can create just one triangle. So we don't really have to think about, well, how are we going to create the second triangle or the other ones? Now we know for a fact that we just have to work with this triangle and this triangle only. So let's work with this triangle. So what exactly do we want to do with this triangle? It says we want to find the remaining side and angles. All right. So how can we start doing this? Well, let's start by using the law of sine. We know that we can only create one triangle, so there's no way for us to think about the ambiguous case. We're only going to think about this problem as if it was just a regular law of sine problem. So if we set up our ratios, notice that if we want to solve for everything in this triangle, we can definitely solve for angle B because we have information about angle A and side A, so we can set it up as if it was the sine of 42, or let me actually write down what I'm going to use. So I can use the sine of A over A to be equivalent to the sine of B over B. We're just going to use it as if it was a regular law of sine, so let's just plug in what we know. So the sine of 42 over 22, that should be equivalent to the sine of B, which we don't know, over 12. So how can we solve this? Well, we want to solve for B. So if we cross multiply and we isolate B, we're going to have the 12 times the sine of 42. That's equal to 22 times the sine of B. So to solve for B, we got to divide by 22 now. So now we know that the sine of B, it's equivalent to this big expression. So 12 times the sine of 42 all over 22. And if we want to solve for B, don't forget that we have to multiply by the reciprocal. So we can multiply by the reciprocal sign, or the inverse, I'm sorry, not the reciprocal. That way the signs will cancel out by the cancellation law. And now we have an expression for B. So now we know that B, it's equivalent to the sine inverse of this big expression, 12 times the sine of 42 all over 22. And this is definitely something that we can use our graphing calculator. So let's just plug this in. But again, before we plug it in, make sure that your calculator, it's in degree mode, which is good. So let's actually plug this in. So we want to use sine inverse of 12 times the sine of 42. 12 times the sine of 42, close parenthesis, divided by 22. Oops, I think I did an extra 2 there. All right, and if we hit enter now, we can see that now B has approximately a value of 21.4 degrees. Let's just put the calculator here on the side for a second. So now we know that this angle B has a value of about 25.4 degrees. So what are we missing? Well, notice that we're missing angle C. So let's work for angle C. Angle C, notice that we already know that this is 21.4 and that is 42. So definitely angle C will be 180 minus 42 minus 21.4. So now we can define as angle C to be 116.59. So now we know that angle C is equivalent to 116.59. So the only thing that we're missing is side C, which we can definitely solve for side C using, again, the law of sine. Because notice that we have a pair. I can set it up just like we did before. So the sine of A over A, that can be equivalent to the sine of C over C, which we notice that we already know what angle C is, so we can just plug that in. So let's just plug this in. So now we can set it up as the sine of 42 over 22, and that's equivalent to the sine of 116.49, because that's what C was equivalent to, and that's that will be over C. If we cross multiply and solve for C, you will see that C is going to be equivalent to 22 times the sine of 116.49 over the sine of 42. And this is just something that we can use our graphing calculator for. So let's just find that value now. So here we have 22 times the sine of 116.59. And that we're going to be dividing it by the sine of 42. And now we have that side C, it's approximately 29.4. And notice that we have definitely solved for everything in this triangle. We know all three angles and we know all three sides. So let's take a look at another example. I want to concentrate on example 3. So let's see what we have here. It says, well, it's obviously a typo, but should say find. So find two triangles for which A is equivalent to 12 meters, B is 31 meters, and angle A is 20.5. Here's a hint. Let's draw a diagram. So let's start by drawing our diagram. So let's define our triangle to be of this form. So let's just label my diagram. Here's A, here's B, here's C, and let's plug in what we know. I know that side A is 12. I know that side B is 31. And I know that angle A is 20.5. But notice how this information is given to us. Again, it's given to us in the form of side angle. So we have to check if we have the ambiguous case of the law of sine. But notice that here the side opposite of the bigger angle, the side opposite of the given triangle is definitely less than the other given side, which is 31. And if you take a look at your notes from yesterday, you will see that this is the case where we could have two triangles. Here's, notice like here, if you think back on the lesson from yesterday, here's our K, definitely 12 is less than 31, and 12 it's in front of the given angle. So this is one of those cases where we're going to encounter two possible triangles. And this is the ambiguous case of the law of sine. So let's just work this out as if it was, this is my first triangle. And we're going to worry about the second triangle later on in a second. But let's, now I know that I must be working with two triangles. So let me not worry and just work this triangle. But before I continue with this, notice that I'm taking for granted that I know that 12 is definitely greater than the height. Because at least by the way that this is defined, the height can be defined as 31 times the sine of 20.5, which if you take a look at your graphing calculator, that will be that h, or the height, is 10.85. So notice that 12 is definitely greater than 10.85, so definitely we can create a triangle. So this is just for you to just double check about the height. But at least for the examples you've been given, uh, most of the time, the second side is going to be definitely greater than the height. But this is how you can find the height. It's always going to be the left or the given side times the sine of the angle. So I now know that my height is 10.85. I know that it's a triangle. And because of the ambiguous case, I know that I must be working with two triangles. But let me not worry about the second triangle yet. Let me just worry about the first. Let me solve the first triangle. So let me solve the first triangle. So what else do we have? I can definitely solve for b right away, because now we can apply the law of sine, which if we set it up correctly, that would be sine of 20.5 over 12, and that's going to be equivalent to the sine of b over 31. And now the sine of b is going to be equivalent to 31 times the sine of 20.5 over 12. And just like we did in the previous example, once you have it in this form, we multiply by the inverse of sine on both sides. So that way, by the cancellation law, b stays by itself. So now we know that b is equivalent to the inverse of 31 times the sine of 20.5 all over 12. And now again, this is just something that we can use our graphing calculator to find the value of. So let me pull the graphing calculator here. So the inverse of sine of 31 times the sine of 20.5, this parenthesis will close out the sine, this parenthesis will close out the numerator, divided by 12. And this parenthesis will close out the inverse of sine, and that gets me a value of 64.8. So now I know that b has a value of 64.8. So what exactly are we missing? We're definitely missing angle C. But notice that angle C will not be that complicated to find the value of angle C, because I know that angle C is going to be equivalent to 180 minus 20.5 minus 64.8. And if we do this in our graphing calculator, let me just do it mentally. Here, C, it's equivalent to 94.7 degrees. So now I know exactly what this angle is. This is 94.7 degrees. So the only thing that we're missing is side C. So let's find that side. So how can we set it up? Well, in order for us to find sine C, I can just use the law of sine one more time. So this is going to be Z over sine of angle C, which in this case is 94.7. That's going to be equivalent to, I'm just going to choose the given, which is 12. So 12 over the sine of 20.5. We're solving for C, so now C is going to be equivalent to 12 times the sine of 94.7, because we're cross multiplying, over the sine of 20.5. And if we use our graphing calculator, which I'm not going to use, I'm just going to write it out. If you would have put this in your graphing calculator, you would have got 34.15. So let's pause here for a second, because now I have properly solved for one triangle. I know the value of all three interior angles, and I know the value of all three sides. But didn't we state it that due to the ambiguous case of the law of sine, we need to have, or we could have, two triangles? So how do we create this second triangle? Well, for that, let me just erase this because I might need some extra space here. So I know that it must be a second triangle. So how do we define that second triangle? So let's see. For my second triangle, I know that I must have the same information. I know that my second triangle must still have the same information here. Side A of 12, side B of 31, and angle A of 20.5. So that still must hold true. So I must still have some kind of a triangle whose angle A, it is still 20.5. Side B must still be 35, and side A must still be 10. Still be 12, sorry. So it must still be 12 here. But now let me call this B1. And again, notice that this triangle is a little differently here, because again, think about it as if this was some kind of a pendulum. So this is the given triangle. Think about this as if it was some kind of a pendulum. If this is 12, and I kind of like move it along here, this is my new point here. And notice that I could still have this new triangle created here, which we have here the same angle as being A of 20, the same side as being 31, and the same side as being 12. That's what I'm trying to recreate here. I'm trying to recreate this triangle, the second triangle that we do have here. That's what I'm going to try to recreate here. And the first thing that you might have noticed is, well, angle B, it's definitely not 64.8 anymore. So what exactly is my new angle B, which I want to call it B1? Well, notice that these two sides must be congruent to each other because they're the same length 12. So you can think of this as being an isosceles triangle. Therefore, this side or this angle, the measurement of this angle, it is still 64.8. So therefore, this angle, which is exactly this angle that I do have here, let me call this angle B1. This angle right here, which is exactly this angle right here, is going to be equivalent to 180 minus 64.8. But why is that? Well, again, this is the triangle this is the second triangle, and this is the one that we're going to concentrate here. I know that this length is equivalent to this length, so I can think of this as if it was an isosceles triangle. Therefore, this is 64.8, this is 64.8, so therefore angle B1, which is what we do have here, should be 64.8 minus 180. That's how we can get this angle right here, which is exactly what we do have here. And that's pretty much how we find our second angle, which if we do this correctly, that's equivalent to just 115.2 degrees. So now we have everything that I know about this. We have everything that we need about this triangle to solve for it. Because now the only thing that we're missing is angle C, which notice that angle C is not going to be 94.7 anymore. This is going to be a new value for angle C. And what's the value for C now? Well, angle C for this second triangle is going to be equivalent to 180 minus 20.5 minus 115.2, which is equivalent to 44.3. And again, this is 44. Let me just fix that. 44.3. So now I know that this angle right here has a measurement of 44.3 degrees. So the only thing that we're missing to properly solve this triangle is just line segment C, which for that we can just use the regular law sine, which we can set it up as 12 or little a over the sine of A being equivalent as little c, which is what we're looking for, over the sine of angle C. C can be defined as 12 times the sine of 44.3 all over 12. And if we use our graphing calculator for this, let's find out what that is. We're going to have 12 times the sine of 44.3 divided by 12. I'm sorry, that's my mistake. This is not over 12. This should be over the sine of 20.5. The sine of 20.5. Because again, if we cross multiply, we're going to have 12 times the sine of C equals sine 20.5 times C. So we're going to divide it by sine of 20.5 in order to get the C by itself. So sine of 20.5 will be in the denominator. So let's actually find the true value for C now. So 12 times the sine of 44.3. That's going to be over the sine of 20.5. And now we have a line segment, or we have a measurement for line C, which is 23.93. I hope that this was helpful. But again, the moral of the story here is that if you've been given any information about a triangle in the form of side-side angle, you have to check any of the three situations. Either we can have no triangle, one triangle, or two triangles. And in this case, we were able to define two triangles based on the discussion that we had in our previous lesson.